Section 2.7, page 4, the final example, example 6. A man walks east, which is to the right, at 4 feet per second. A searchlight is located on the ground 20 feet from the path. So here's the path the man is on, and is kept focused on the man. At what rate is the spotlight rotating when the man is 15 feet from the point on the path closest to the searchlight? Okay, so we've got a visual given here, that here is this path that the man is walking on, and here is our searchlight that's on the ground, and it is rotating from the angle that it's pointing at to be following the man. Now, it does say it's located 20 feet from the path, and so it really feels like this should be more of a straight line for the 20 feet. But we're just kind of, at this point, given that it's a distance. So don't worry too much about that. Because we're asked at what rate is the searchlight rotating, rotating is referring to the angle of the searchlight. But let's go back and start with all the given information. The man walks east at 4 feet per second. So we're seeing that the man is walking along the side of this triangle that is X. And because walking is a speed, we'll say, then it's not just x equals 4, it's dx dt, because his time is changing, and because he's walking away, his distance is getting bigger, so it will be a positive. We're also told that up above in the question, the spotlight, or I changed it to spotlight from searchlight, is 20 feet from the path. So the spotlight is 20 feet away. Now, we don't have a variable for this piece. We have a number, but what we'll care about is that it's adjacent, the side closest to theta. And then the last piece of information said when the man is 15 feet from the point by the searchlight. So 15 feet down the path. So we specifically want to stop when x is 15. And x is opposite theta. Okay, so now let's go ahead and talk about this a little bit. So we've got that picture, and we can see it as a right triangle, even though that's not necessarily how it's drawn. But the problem is we only want a right triangle if we're worried about the hypotenuse using the Pythagorean theorem, and that's not what we want. The question is asking for the rate that the spotlight is changing, which we said is the angle. So we want d theta dt. So we really need to focus more on theta. So we know that it said that theta, the adjacent side, is 20 feet away, and we have x, the opposite side. So thinking of SOHCAHTOA, then if we have the adjacent and the opposite, that means we have the information for finding the tangent. The tangent of degree theta consists of the opposite side divided by the adjacent side. The opposite side, it's just x, it's not a value, but the adjacent side is 20. So taking this statement up above here, coming back to just rewriting it so it's visually easier to see, I want to take the derivative using implicit differentiation over time. So I'm going to, I said, let's go ahead and think of x over 20 as really being 1/20th, a coefficient, multiplied with x. This might help with the derivative. The derivative of the tangent is the secant squared. And then because we're taking the derivative of theta, we need to put d theta dt. Coefficients stay there. The derivative of x is 1, but because we had an x, we need to write dx dt. Next step is always to plug in the values we have. We really only have one value from that formula, which is dx dt is 4. We don't have anything for theta or d theta dt. Keep in mind, even though we're not given anything from the figure for theta, or in this case, secant squared of theta, we can figure this out. Secant squared of theta is the same thing as the secant of theta squared. So we can just go ahead and focus on secant of theta first. Maybe you know that the secant of theta is the hypotenuse over the adjacent, but if you didn't, hopefully you at least remembered it's 1 over the cosine. And as we stated a few minutes ago, cosine is adjacent over hypotenuse. Then we can really think of this as 1 divided by adjacent over hypotenuse. My H looked like a B. And so we would multiply by the reciprocal and just get hypotenuse over adjacent, like I said, or maybe you knew that. So we've got the secant of theta is hypotenuse over adjacent, and we know what some places the adjacent can be swapped out as. We know what x is, but x is not the hypotenuse. X is the opposite. We want the hypotenuse. This is where the Pythagorean theorem comes in. If this was A, B, and C, I'm squaring A, which was 20. I'm squaring B, which we know is a value of 15. And I'm squaring C, but I went ahead and wrote the letter H since we're talking hypotenuse. So I square the numbers, I add them, I take the square root of both sides, and we get H, or the hypotenuse, is 25. Coming back to the secant of hypotenuse over adjacent, the hypotenuse we just found to be 25. The adjacent was given to us in the question is 20. And if I divided top and bottom by 5, I can simplify this to 5/4. So the secant of theta is 5/4. But remember, we had secant squared of theta. So it's that 5/4 squared, and we have 25 over 16. Let's go ahead and pull this together again. So coming back to this line, secant squared of theta, we just found to be 25 over 16. D theta dt is the term we're trying to solve for. And we already had the 1/20th times 4, although 4 will divide into 25 times. So what we can do is leave the 1/5 on the right side, divide both sides by the reciprocal, which would be 16 over 25, so that I have d theta dt alone on one side. And as I multiply across the tops of my fractions and the bottom of my fractions, the numeric value of my answer, the rate at which the spotlight is rotating, is 1625ths. But what are the units? So notice that theta is measured in radians. Theta is either degrees or radians, but the way we solved it was in radians. And the information we have is that the man was walking in terms of feet per second. And so therefore, we're going to use seconds as the measurement of time. It would not be feet because the theta doesn't rotate in terms of feet. It's rotating in terms of radians.